Hi, my name is Gus Apostle, and I'm a program manager on the Windows Azure storage team, and today we're going to be talking about Azure Table Storage. Over the next 30 minutes, Azure Storage will handle over 23.5 billion transactions. It's a foundational building block for all of our products and services, and we want to offer the same capabilities to you for building your cloud scale applications and services. Now, we're built for hyperscale. We handle over 100 trillion objects in storage today and over 12 million transactions per second. We offer a variety of durability options, including local redundant storage and geo-replication. And we're the only storage platform that guarantees when your data is written locally, we can actually replicate it in a geographically dispersed location over 400 miles away using geographic replication. We have 3 nines of availability for reads and writes, and you can actually add an additional 9 of availability for reads when you're using read access replication. We're an open platform. We support all of the REST APIs, and we have a comprehensive set of client libraries such as .NET, C++, Node, Python, and Ruby, just to name a few. With the upcoming release of Windows Server 2016, the new Azure Stack will give you 100% consistency for developing applications that you can run on-premise, in a local hoster, and also in the Azure public cloud seamlessly. So let's talk a little bit about some of our storage offerings. We have 2 product offerings. For developers, we have blobs, tables, and queues. Blobs are our highly scaled object store, and they're optimized for storing things like binary data, such as pictures or videos or backup files, IaaS backup files. Tables are our massively scaled NoSQL store for your structured data, and queues are very useful when you're decoupling components in your distributed application when you need to scale them independently. For VMs, we have disks and we have files. Disks are what essentially backs your IaaS VMs. We also have a premium offering if your workload demands very low latency, meaning sub 10 millisecond, and predictable high throughput. And then Azure Files are essentially our fully managed public cloud file share system that gives you complete consistency in terms of on-premise versus cloud file share. So great for lift and shift scenarios where if you want to move some of your legacy code applications to the cloud, you can do so seamlessly without any code changes. I put a link down at the bottom of the page, and this is for our Azure storage documentation. Go to azure.com and you can learn a lot more about all of these data abstractions that we offer on Azure Storage. So let's talk a little bit about what is the Azure Table Storage Service. For scenarios, let's think about something like a shopping cart where you've got thousands of items online that you want to surface to your users. Each item is uniquely identified by an ID, and we use that ID to link to a set of metadata properties about that item. User clicks on the item, you need to very quickly look that item up and get that metadata to your user to see if they want to buy it. Things like price, location, and availability, for example. Xbox Live also heavily relies on Azure Table Storage for managing things like gamer profiles and gaming experience. Skype uses tables for doing things like call routing and managing a list of call routes for your devices. So these are some scenarios when you would use the Azure Table Storage service. Let's talk a little bit about some of the characteristics. We are a key value store, so we're optimized for key-based lookups, and we can store hundreds of terabytes of data, even petabytes of data if you so choose to shard across multiple storage accounts. We're strongly consistent, meaning that for every write, we guarantee at least 3 copies of your data will be written to disk. We also have dynamic resource allocation. So under the covers, when you're seeing bursty or sporadic workloads, we can automatically do load balancing of your data over hundreds of servers so we can keep servicing requests at low latency. And all of this allows us to do very high transaction volumes at a pretty compelling cost point. So I want to take a look at some Azure storage concepts. Let's talk a little bit about an example where a company, we'll call it Contoso, is building a set of cloud applications and they want to build it on the Azure platform. So when they build, what they first need to do is sign up for a subscription. And you can have one or multiple subscriptions. And each subscription can have one to many storage accounts. Now these storage accounts are where you actually store data across all of our data abstraction, blobs, queues, tables, files, and disks. But today we're talking about tables. You can have as many tables as you want in Azure Storage today. Now, if there's one thing that you take away from this session today, I want it to be this. What you select for your partition key and your row key is absolutely critical for successful table design. We use the partition and row key combination to help us group your data, help us do things like auto load balancing, which I mentioned earlier, as well as giving you the ability to do atomic transactions over that data. So very important to enable us to be able to scale your data and enable you to be able to accomplish thousands of transactions per second for your applications. So what makes a good partition key? Well, the Azure storage system is a range-based partitioning system. So the more that you can spread your keys over the lexicographical key space, the better chance that we have to actually observe your query patterns, your data access patterns, and then help you scale that service appropriately. Now, I've just hit some of the very surface topics here. I highly recommend that you check out the link at the bottom of the slide here on the Azure Table Design Guide. We go into a lot more depth and explain a lot of these concepts in a lot more detail, as well as having some examples. We talk about patterns, how to choose your keys, when you might use something like a composite key for flexible query design, and so forth. So highly recommend you check that out. All right, so let's keep drilling down into the table structure itself. So as an example, I've got a gaming example here. Let's say that we have a massively multiplayer online game that has hundreds, if not thousands of users, and each user has hundreds of properties that make up that user's gameplay experience. Very simplified example here. You can see my table. As the name suggests, data is stored in a tabular format. And we store what we call entities. So you can think of an entity in relational database terms like you would think of a row. Now each entity has a partition key and a row key. This key combination is what we use to create the clustered index for the table and also enables us to do very fast point lookup queries. Now entities within the same partition all share the same partition key value. So a table server can handle multiple partitions, but a partition is actually handled by just a single table server. Now row keys are what we use to uniquely identify a set of entities within a partition. And you can see here I've used gamer profile. For my partition key, I used gamer ID or user ID, which is a great key because it guarantees me randomness and uniqueness, which allows us to distribute data more effectively. And then finally, we have a set of properties. You can think of properties like columns, except for there's no schema enforcement for those columns. Every entity can have between one and many properties. And those properties are essentially name-value pairs of metadata that make up that entity. So these are the very basic concepts of what an Azure table is. And at the bottom here, I'd love for you to check out Jeff Irwin's presentation that's also on Channel 9 that goes into a lot more depth in some performance, scalability, security, and design patterns that will be very helpful in helping you get off the ground and building your applications on Azure Table Storage. Two other things that I want to mention that are also critical to your design is entity group transactions and table concurrency. So when you need to execute a set of operations atomically over a group of entities, you can use what we call entity group transactions. And this allows you to accomplish batch operations over a set of entities. It's scoped within a single partition, and you can have at most 100 entities in any given batch job. Now, it's important to keep in mind that if you're doing multiple concurrent transactions and they involve the same entities, you need to make sure that you're aware of that, because you could get conflicts. And those conflicts could result in either a delay in processing or even the entire batch failing. And transactions are an all or nothing in terms of success. So if any part of the transaction actually fails, the whole transaction fails and is rolled back. So that's something important to keep in mind. Many modern day applications today have multiple readers looking at data and updating data concurrently. So think, for example, about a wiki page where you've got multiple people that are looking at that page, and then you've got sometimes folks that are actually updating data at the same time. The wiki platform has to be sure to understand which writes are succeeding and which are not, and make sure that the users doing those updates know if their write was successful or not. And so the Azure Storage Platform actually does support all three models for concurrency. Pessimistic concurrency, where we actually would lock the object, make the update, and block access until that update is complete. Optimistic concurrency, where you might receive something like a token, which you could use later to check and see if that data has changed since you last updated it. And then a last write wins strategy, which means whoever wrote the data last, that's what's going to be the most current row. Now, tables defaults to optimistic concurrency. So when you store a row in a table, we actually will append a timestamp column, which we use to track the last modified time. Now, that's a column that only we update internally. You can't change that. When you actually receive an entity from the table, you get what's called an E tag, and that E tag is derived from the timestamp, and it's what you can use in your update statements to check and see, has that data changed since I last retrieved it before I do my update. Okay, so those are some of the basic concepts around Azure Storage Tables. I'd like to step in now and let's take a look at doing a demo. To prepare for this demo today, I went to azure.com and I installed the Azure Platform SDK. And when you install the SDK, you get a couple of great features that I want to show you here. First of all, when I create a new project, I've now got under templates a brand new set of quick start templates. And here you can see I've got Azure Storage Tables as one of my examples, which I'll bring up. The second thing that I get is called the storage emulator. So if I don't want to spin a workload up in the cloud and do dev test against that, I can actually use the emulator. So if I hit the Windows key and I start typing emulator, you can see I get the Windows Azure Storage Emulator. Now this is a pretty cool feature because it essentially acts like I'm connecting to Windows Azure, but I'm actually just using the local store and the emulator to emulate transactions from the server. So you can see I get a great little message. I've got a nice little icon down here that allows me to manage the emulator. And then my storage example here has a great quick start guide that essentially walks me through how to get started. So let me bring up the project that I started earlier because I've got a few breakpoints, and we'll actually use that one for stepping through some code. Okay. So we're going to do some real basic stuff here to start with. So I'm going to step in and we're going to just show you how to create a table. Now, remember earlier we had talked about storage accounts. So essentially the first thing I need to do is go get the information about my storage account. And then I can use that information to create a table client. Now that table client is what I'm going to use to interact with the Azure Table Storage Service. Okay, so we get that information, and then we're going to create a reference to it. And then if the table doesn't exist, we'll create it. If it does exist, it'll let us know. This should be a fresh demo, so you can see that we created the table successfully. It's pretty much just that simple to get a table up and running. That was it, just that few lines of code. All right, so let's keep going here, and let's look at some of the basic CRUD operations. So create, read, update, and delete. So in this example here, you can see I'm creating a customer entity. For my partition key, I've chosen the last name, which is Harp. And for the row key, I'm choosing Walter. And then you can see I'm also adding a couple of properties. I've got email and phone number there. I can also update that entity. So all of our entities support public setters and getters. So I can actually do an update to that. And then I'm going to go ahead and insert it into the table. And as you can see, it was very quick, inserted, and you can see that we inserted that row into the table. And just the same, I can also supply that table object as well as that same entity and do the delete, and it will delete the row. Now I'm going to step through here and do a couple of a little bit more advanced operations, batch and query operations. So first let's look at a batch and see how easy that is to do. So this is going to be a very basic batch operation, and I'm not going to step through all of this code here, but basically what I'm going to do is I want to load up 100 entities, and then I want to insert them all at once. So I just stepped over that code, which essentially did my population of my entities, and then I simply do a batch execute, which executes all of those together. Now, again, I'm not going to step through each iteration to show that we actually did the insert, but if you look at our UI here, you can see that we've actually gone and, in fact, inserted 100 new entities into our table. All right, so let's take a look at doing some querying of some data. And the first thing, remember we talked about row keys, and row keys uniquely identifying a set of entities within a partition, and I can do effectively range queries using that row key, and that's all I'm doing here. Basically what I want to do is specify the partition key, which was the last name of Smith, and then I've got the row key, start point, and end point. Okay. And so something that I haven't talked about yet was a continuation token. So I actually have the ability to chunk back rows from the server at whatever granularity you choose. And so that token allows you to keep chunking back the rows from a result set until you've actually completed that. And then it'll come back as null, and you know you've got the end of the result set. So here I'm just using 50 as my granularity. And again, I'm not going to step through each of the iterations, but we'll take a look at our UI after I step through that, and you can see I actually went and got from 1 to 75. So I was able to very effectively and quickly do a range query for the partition key of Smith. All right. Sometimes you may find that you need to do a partition scan and you want to retrieve all of the entities. So here you can see I'm just going to give the table object, and I'm going to give the partition key of Smith. I'm going to create my query object, and then I'm actually going to go in here and execute that query. And again, I won't step through this, but you'll see that I'm able to get all of the rows, or all of the entities that are in the partition with the partition key of Smith. So I realize this is very basic. You can run the same sample. You can either go to the Getting Started guide in Azure.com, or else you can just, if you're using Visual Studio and you have the templates, you can load them up there. I believe that you can also get these same samples on GitHub. So last thing we're going to do is simply delete the table just for cleanup, and I'm not going to run through that at this point, but that's the completion of it. So earlier today, I went and ran the same exact sample set, except for I didn't delete the table at the end. And I used my Windows Azure storage account so that we could look at a couple of things. Now, if you go to my account here, you can see I've got my storage account, I've got all of my services, blobs, files, tables, queues, I've got some diagnostics there. If I click on tables, what you'll see over to the right here is I can see my table, but if I click on that, I can't see the data in that table. So at the end of March, we're going to be releasing the new Cloud Storage Explorer, and it's going to be working for tables. Now, this is a really cool feature. We already have it for blobs and for queues, but we're adding this new for tables. So here I've gone and you can see the left pane here, I've gone and drilled down on the tables, and I've actually clicked on that same customer tables, and over to the right you can see all of the entities in that tables with partition key, row key, timestamp, and the property. So this is very cool. The other thing I can do is click on the query tab here, and we've got some common queries that you can actually do to query that data. I can add to that data, I can delete data, I can edit it. Over here back on the left pane, I can actually create a new table and drop tables. So complete manageability over your tables. So this is really exciting functionality. And again, this is going to ship probably around the end of March of this year, 2016. Now, to lead into the last couple of concepts, I'm going to right click here and I'm going to show you something called Attach Storage to SAS. And SAS actually stands for Shared Access Signature. So anytime that you're building applications in the cloud, there's a couple of considerations that you need to have. And one is around security, and the other one is around DevOps, the ability to support that service once it goes live. For security, we actually employ 3 access control strategies. The first is storage account keys. So essentially, that gives you administrative access over that storage account, full rights. Now, you don't necessarily want that storage account key running around your enterprise with users or untrusted devices. So we developed something called Shared Access Signatures. And what this is it essentially gives you the rights to create a token, if you will, with a granularity set of permissions over any of the storage objects. So for example, for tables, if I'm an ISV and I've got multiple customers in a table, I can actually create a shared access signature scoped just to the range of data. So for tables, you can actually specify a range of data for that particular customer. I can specify granularity of permission, so I can give them read permissions or maybe read write or read write delete, any combination therein. I can also specify a time that's actually valid, start and end time. And then for very explicit situations, I could also add an IP or an IP range, which will lock down where the requests can come from. And then finally, I can also lock down things like the protocol, so HTTP or HTTPS protocols. Now, the shared access signature is just a string. You can see the little graphic that I have at the bottom there. It's just a string that you append to your URLs. And the token is actually generated from the storage account keys, so we can actually validate its authenticity on the back end. Now, another consideration, when you've stood up your service in the cloud, it's important that you're able to do DevOps for that service. And that means understanding the health, the well-being, and the performance and how your users are experiencing that service in the cloud. So we've got a couple of great features. First is called storage metrics. Basically, think about that as perfmon in the cloud. We give you over 40 metrics that you can look at about your service and the health therein to enable you to get a sense for how your users are experiencing your service currently. Now, the interesting thing about that is we actually store that data in Azure Table Storage. Now, when you need to actually pinpoint and you're troubleshooting a complex problem, you might need a lot more granular information. And so we also have something called analytics logs. And essentially, think about this as IIS logs in the cloud with a lot more granularity over the data that's getting logged. So all of your REST API calls can get logged, or some combination if you want to keep the log size down. We include all of the standard stuff that you may think about: endpoints, timestamps, latency, status codes, what operation was performed, all of those things to help you really pinpoint and identify what's going on within your service. And those are actually stored using blobs. Now, there's a couple of things I didn't mention here. We have client-side logging available to you, so if you want to instrument your clients and get some information there, you can do that, as well as the ability to do things like network traces. Network problems are very hard to diagnose, so being able to load a network log trace and look at that also equally important. And then we've got something called the Message Analyzer tool. And what's great about this particular feature is using a correlation ID that's shared by all of these log services, you can actually stitch together all of the sources to give you an end-to-end point-in-time look at what's going on your service in a chronological order. So very powerful for troubleshooting and diagnosing problems in your environment. A couple of other data services that I wanted to talk about just briefly. We went extensively into tables. Let's say that you're storing primarily JSON documents, and most of the data that you're storing is JSON in nature. You could use the fully managed service DocumentDB. Now, DocumentDB gives you some really great features, especially if you're storing things like JSON documents. So first of all, we automatically go and index all of the properties within your document, and we expose a rich query interface, transactional scoping, and we can do all this with very low latency. So if the nature of your data is primarily documents, consider DocumentDB as a strategy for storing that data. If you're storing relational data, and you don't want to stand up something like an IaaS VM and start up SQL Server and manage it there, you can take advantage of Azure SQL DB. It's a fully managed database service, and as of SQL Server 2014, it's fully compatible with the on-premise product. It has all the same features that you've come to know and love from SQL Server: disaster recovery, high availability, transactional consistency, as well as a couple of other features such as elastic database pools when you're building things like SaaS workloads. So that's also a very compelling offering if your data is relational in nature. So just to summarize here a bit, the Azure Table Storage Service, highly optimized key value NoSQL store, optimized for point lookups or key-based lookups. We can scale to hundreds of terabytes of data, petabytes if you decide to shard that data. We're strongly consistent, guaranteeing you 3 writes for every write on disk. We have dynamic resource allocation to do load balancing and take care of the heavy lifting of managing your sporadic workloads under the covers. And we can handle very, very high transaction volumes with all of this feature set comprehensively at a compelling price point. I really want to encourage you to take a look at the Getting Started with Azure Tables document. I put the link down here. I've given a couple of different links today. The table design guide for a very in-depth look at designing your tables and all of the things that you need to think about for that. But also a quick getting started guide. If you want to get started in 5 minutes, go through the tutorial sample that I went through in code here today. All of those things are available on the link, and you can find all of this on azure.com. I've included a few other additional resources here that you can look at, including managing concurrency and monitoring for DevOps. I thank you for listening. I hope you have a great build.